Let's move on to the third and final panel, where industry leaders will discuss the critical role of driving simulator calibration in the advancement of advanced driver assistance systems, ADAS. Gain insight into the meticulous techniques that are driving the development of safer and more efficient driving experiences. Join moderator Michael Hoffmann and esteemed panelists from Ford Factories, Porsche Engineering, Lamborghini, and Mercedes-AMG as they explore the complexities of ADAS collaboration and its impact on the future of automotive innovation.
Okay, let's get started before everybody leaves. I already heard that the pizza is already. So Tille at least.
Don't tell them.
I should mention it.
Sorry.
Before we start, let me make two remarks. You know, when I started in the industry, admittedly it was a little bit time ago, vehicles were developed, and when we were very close to start of production, then the controls development started. If I look at our program today, and let's say that we think that Guido's presentation is start of production, so we were finally done, I get the impression nothing has changed, so controls is an afterthought. But maybe there's a second explanation. So maybe we kept the best for the last point to motivate the sticks really here at the end. And if I look at the participants of the panels, I think the second is true. My second observation is, I don't know whether you also recognize it, I don't have a chair. So Gabriele doesn't want that I'm feeling too comfortable, so that I'm making sure that we are finishing on time. And that's what we're going to do. What we will do at the beginning is we go round our virtual table, and with Jens starting. So everybody will talk about, okay, what they're doing in the area of vehicle controls development and ADAS development. So Jens.
Yeah, thanks for handing over to me. Jens Dornhege from Ford Werke GmbH. Currently, I'm supporting a team of engineers responsible for the steering side of ADAS functions. So, receiving from the ADAS module the information where to go and how to go there, for which feature, and converting this request into the torque supplied to the steering system. We do this development from cradle to grave in designing the functions, discussing the feature content, programming the functions up to a software library handed over to the supplier for integration. And we also do the application in vehicle up to final tuning and support the sign-off. My history is a bit, I'm coming from gear engineering, went over to vehicle dynamics, doing ADAS simulations, full vehicle and suspension. From there progressed to being the simulation support for controls engineers, working on active systems, progressing into a project lead of this active dynamic systems, and now went into product development, being the support for this team.
Okay, hi, my name is Tille Rupp. Also, warm welcome from my side. I'm happy that there's still some people left here, despite the pizza. I'm head of simulation at Porsche Engineering. Porsche Engineering is an engineering service provider, 100% owned by the Porsche AG and part of the VW group. We are small but great, 1,800 people worldwide, Germany, Romania, Czech Republic, China, and US. And I'm leading a team of engineers in Germany, 18 people, and around the world, 20 to 30 engineers. And we're focusing on simulation. Simulation is obviously a very big word, and we have, I would call it focus areas, because we serve in our simulation competence in a cross-department approach. So we serve as supporting other departments such as ADAS department or chassis department, full vehicle department, and so on. So our focus areas are, for one, and this is our, I would say, longest competence or historic competence, we do XIL modeling for hill test benches, SIL test benches for full vehicle models. And what we have evolved, I would say, kind of naturally with all the ADAS development in the past 5 years, we have evolved towards ADAS simulation. So we have a clear focus on the full vehicle models, but also on everything that you need for ADAS hill or SIL test benches. So the virtual environment, we have developed a tool chain that allows us to generate virtual environments based on either own measurements or measurement-based data that we get or map data. We also deal with generating scenarios, and by scenarios, because we have, I think, a lot of definitions used within this conference here. By scenario, I mean the definition or modeling of the surrounding traffics. So we have an ego vehicle that we want to test with the ADAS function, for instance, but also V2X functions could be possible. And we have to have the static environment, we have to have the vehicle model, and we have to have the surrounding traffic, which we need to interact with as an ego vehicle. And the last thing, which we are now starting to develop and look closer into, which is kind of natural, I would say, going from SIL to hill, is now how we can apply driving simulators. It is new to us, but we are building up on the competences that we have for virtual environments, the scenario modeling, and the XIL models that we have developed in the past and are still doing.
Thank you.
So, good evening to everybody also from my side. My name is Lorenzo Fasani. Thank you for the opportunity to join this panel. I'm the coordinator of the ADAS development at Lamborghini. I've been working in the ADAS world for 10 years, almost 10 years. At the beginning at Audi with autonomous emergency braking, and now at Automobili Lamborghini. I think that the ADAS world is a very nice world, because there are a lot of interfaces, and this makes the job very interesting and very dynamic. We have interfaces towards HMI, we have interfaces towards the vehicle dynamics, and that makes the job, the everyday job, also very thrilling. We are a discipline where usually we work in the car, in the physical car, but now we have also from our side the need to jump in the simulation world to make our work faster and more efficient. So also at Automobili Lamborghini, we are setting up a simulator, an ADAS simulator, and basically on a scalable concept so that we can add additional parts with the time. We're starting with the camera-based function, for example, emergency lane keeping. So we have a camera hill included in the simulator, and we have both the possibility to have online and offline simulation. So depending on the target, so for example, some functional evaluation can be done offline, some calibration or pre-calibration can be done online with the driver in the loop. And basically, yeah, so very dynamic also in the methodology. That's why I like ADAS world.
Before we go to Michael, it's, you know, when I listened to the first presentation today at Bentley, they were saying, let's say nobody wants to fly a prototype airplane, but everybody likes to drive a prototype Bentley. He was saying in Sweden. I would assume with your cars, there's also the preference to drive the car. So I think one of the areas could be the Nürburgring or even Sweden if you like snow. So how do you motivate, what's your recipe that you motivate the people not driving the car and using the simulator?
It's actually very difficult because, I mean, I also like to drive our cars, okay. Who wouldn't? And I mean, the fun fact in the job has to be there. But I think that the fun fact can be found also in different methodologies, in some new challenges. And moreover, there, of course, also the necessity to be efficient and optimized. So, okay. Yeah, we have to do it, we need to do it, but we do it in the right way. So that's probably the secret for doing it right.
And I think Michael will confirm that also riding the simulator can be a lot of fun.
Yeah, it can be lots of fun. And especially it helps you to actually get on the car, because nowadays cars are that complicated and it takes us actually a long time to get them going and do our work in digital world and real world. So that's enabling everybody or helping us getting the guys in the simulator and doing their work there or doing the offline work together with us, because they can actually spend more time in a working car and do the calibration work and be happy with what we achieved.
Could you talk a little bit about the control systems you deal with?
Yeah, I'm very good with ADAS system as well. I'm good in switching them off before we go to the racetrack. No, but actually, we don't do control systems ourselves, but right next in our next door neighbor team, we actually help them. First of all, we supply simulation models for cluster testing or the offline testing. We help them testing their system, their control system, and analyze their control system in the digital world. And what we really, we did loads of work in the past years. I mean, you heard what Max yesterday told us about lowering the hurdle for non-simulation engineers to actually go in the digital work, do their work there, solve their problems on the simulator, offline, define easy maneuvers, and just be able to do work there. And not to forget, I mean, at the end of the day, real-life testing is important. We all like it. Nobody wants zero prototypes, by the way, apart from VI grade. But you need to get there, and you need to be there efficient. And everybody wants to be efficient. So if it helps, let's do it.
Yeah. Also connecting to previous panel, let's talk a little bit about collaboration. And maybe Jens, you will be a good person to start, because you're doing lane keeping assist. So basically you get the steering from someone, you get the vehicle model from some other places, and maybe you can share a little bit best practices and your experience.
Absolutely. So collaboration is a must-have. So our goal, starting with the simulator, was pre-calibration of lane keeping assist to reduce time in the actual prototype vehicle, to have a better starting point and only do validation and refinement. To do so, of course, you need to start with a valid vehicle model. We don't do the vehicle model ourselves. We are steering experts, but we get it from the vehicle dynamics team inside Ford. So that's internal collaboration. We need to have a very valid steering model, because the torques to be fed in there must be somewhat precise. So the assist function reacting or working with these torques and damping and everything must be precise. So we receive software in the loop models from our suppliers. And these are based on the current software as it is in the vehicle. We use the same calibration as it is in the vehicle, including all stability filters. And to do that, you need a very valid steering plant, which is also delivered by the supplier based on internal measurements of the single parts built in there, and with their friction and everything. Next you need to have is a valid camera model, of course. As you said, we're also using a camera hill for that. That's another part of collaboration. We need to collect all these parts, and not to forget, you need to feed these systems with valid CAN signals. Otherwise, they don't work at all. So you need a good rest bus simulation, which in turn is another collaboration inside our company, where we have set up a set of, simplified libraries of the single modules providing the signals on the CAN to do the rest bus simulation. Because you don't want your simulation models to be too complex. You can't have every module in the car simulated. It would slow down everything. It would be too complex. If you do steering evaluation, you don't need a hydraulics model of an ABS system. And you don't want to have the complete ABS system on board, you just need the signals, which are relevant for you. So there are lots of dependencies, and this can only be resolved in a team.
So when you start the project, you already have the specification, which you then give to the suppliers? Is this how it works?
Yes, we have a statement of work for the beginning. We have our specifications. We do integrate our in-house lib as said into the supplier software at the steering system. Have a very valid interface specification for that, defining all data types to be handed over. And yeah, work from there.
Impressive. So Tille, Volkswagen Group. This is a huge company, I assume, and all of them are your customers. So, what are some recipes to have the collaboration most efficiently?
I have to say I can totally relate to what you said, and I would like to add something. So for us, doing ADAS simulation and working on hill and sill test benches, what is key from our experience is that we can share data. And share data not on a, and this is, I would say, new to automotive industry, we need to share data on another level. So for instance, virtual environments, we need to share track modeling data, or we need to share scenario descriptions. And what is key there is that we can rely on standards. So for us, as an engineering service provider, we have to work, oh, that sounds awkward. We serve our customers, obviously, and they have specific needs on the tooling that we need to use, for instance, the tool chain on a hill, and we serve different customers, so we need to use different tool chains. But what we would like to recycle is the input data, so the track models, the scenario descriptions. I mean, I think we all, at least in ADAS, we think about a scenario catalog that specifically to the test case description, which in our case we get from the ADAS development teams, we can then just take and reuse. And I think this is something where we can base collaboration on. And I have to say, this is, for instance, we use or rely a lot on the ASAM standards, because this standardization is key for us to speed up. I mean, I'm a simulation expert, and I think ADAS, which is great, I wanted to add that, I have to say it now. ADAS for me is like, no one questions that we need simulation anymore. This is the first time that I don't have to argue that we need it. It's one part of the thing, so I disagree that we will not use prototypes anymore, but we have to. And I think it's helpful as well, because real testing guys, they are always afraid of simulation people, right? Mm-hmm. So now we can say in ADAS, we need it all. We need the simulation, sill, hill, and real testing. And now I lost my train of thought. So for the first time, it is clear that we need the simulation, and that we need to reuse the data, because there's so much that we need to validate and test, that if we cannot speed up, we will not make it.
I think that's the advantage of ADAS. It's a new field, and there are not the colleagues who said, okay, look, Tille, we have done this for 30 years.
Exactly,
and,
I take my car,
take a little bit time and get used to it, to how we work. So I think that's the beauty of ADAS. It's a new field where you can define new processes and and achieve zero prototypes.
Yeah, for sure. I mean, the standardization also of the process for ADAS, it goes. It is something that we need to do, as you both said before, and we have a lot of interfaces. So maybe the vehicle dynamics was kind of ahead in the simulation field, but they are also interacting with us in our control systems. So HMI, we had the panel yesterday, they also going towards the simulation, and we are also interacting with them. So basically, standardization and collaboration, I think they are two keywords for the challenges of the future, since ADAS is a cross-functional domain, basically. So we need to work together also to achieve the result, and to achieve the result with 0 point something prototypes.
We're iterating the right direction. But let's review a little bit more in depth what's possible today. So, Michael, you said you don't do control systems, but you run the simulator.
Yes.
And so, let's share with us, so how is the simulator used when it comes to control systems? So do the people just validate that the function is working, or do they, for example, take torque vectoring?
Yes.
Do they do a pre-calibration so that they don't have to spend so much time on the Nürburgring, things like this?
Yep, all of that, yes.
All of this.
I mean, obviously, functional development is a really big part, especially if you look into BEVs and all the control systems coming up with, to us with torque vectoring, front-rear distribution, and giving us huge benefits with the dynamics of the torques you can create. But you need to control that, all that, and yeah, you need to develop these functions, you need to test the functions. Most of the time, the control system engineers are not the best friends of the digital development, funnily enough. So yeah, you need to really get them slowly on the on the simulator, really attracted, and find small crumbs, maybe bigger crumbs, and then all of a sudden they actually say, oh, it's really helping me. I can find things here I maybe would never discover in real life, and I can use the simulator similar to real life as well, because I can actually have the random effect as well. Loads of functions are defined, software-defined functions are defined. Okay, I want to solve that problem, I want to have that function. Then you have a test scenario for that function. Everything works perfectly fine. And then you go testing and test the function in a different scenario, different environment. And all of a sudden, it doesn't work anymore. So there on the simulator, you can actually test variations again. And what helps as well is like get the people or enable them to work in their environment. So our control system guys, they actually come to the simulator, plug in the Ethernet connection, and they are in their world. So they're using their plotting systems, their calibration systems. It looks like they're sitting in a car, and it just helps them to adopt to the digital world. And then obviously, if you got a good digital twin, if you got the perfect tire models, we heard there are loads of perfect tire models. If you've got the parameters for these tire models, can be a task as well.
Don't say so many ifs.
No, everything easy done. But you can actually do loads of pre-calibration, and you use the time you got on a prototype, as long as we still need them, for your work you want to do, and the fine-tuning.
But my impression also is, since I think you are now sharing a validated vehicle dynamics model with your controls people, so you also provide value to them.
Yeah, definitely.
So,
and vice versa.
Yeah.
Because it helps us again getting in discussion. I mean, one big benefit is as well that the people talk together. Actually, the vehicle dynamics guy is there, the control system guy is there, and they talk together about the product and talk about like strategies, how they want to set up the car. I mean, if you got like 5 different systems to create agility, and the vehicle dynamics guys is searching for stability and yaw damping, then it might be a good idea if they get to talk to each other. And it's easier for us to share a model or help them using the model than translating different data sets in different languages for different vehicle dynamics models, bicycle models here and there, and so it's much easier and much more beneficial for both parties, because once they work with the simulator, they are very happy to bring the functions as well, which help us to have more maturity and more reality, really.
So I think it's Max. Yeah. Can someone give Max a microphone? It's coming.
Hello. Hello. Hi.
Hi.
So it's me again, Max from Volvo Cars. So I mean, it was briefly touched upon, but in my world, I think autonomous driving or ADAS systems, it's part about sensory detection and then decision-making logic. And there's quite a big discussion about, you have to make a lot of miles for homologation or not sub-optimize your function for a limited subset of scenarios. Once again, the scenario thing. So I think my question is like, how do you go about with the verification of your ADAS system when it comes to the environment or the scenario editing? Like, how do you build up a library and how do you create enough mileage to fulfill homologation?
Whom do you ask?
I think it's...
Well, actually, as I told before, we are setting up the simulator. So this is the question that we are facing now. I think that in the first phase, it's important to recognize where we can have the most out of the simulation. It doesn't have 100% at the beginning directly. So, and there are a lot of aspects that can be simulated. For example, the function logic is something that you can address singularly on a simulation. Then there's scenarios which are quite standardized, like, for example, homologation scenarios or rating. These are scenarios where you can basically also the scenario themselves in the regulation, they are standardized. So you can do almost fully in a simulated world. And then there is the part about the real world. And this is the part where currently, I mean, this is the challenge for the future with having, for example, if you're using the sensors as a hill, then you need to have a photorealistic environment, for example, for a camera system or a precise radar simulation. So this is exactly the step that we have to address in the next years, in my opinion.
Okay. And maybe also a good topic later for the pizza party. Because,
Can I add one thing? So Max, I mean, this is, one. I think this is one of the key questions, right? And I would say mileage is not the answer. So you need critical situations that you test. What we currently do is we look in reality. So we do test drives in reality, identify always function-specific critical situations, and then we call it scenario sampling, scenario word again. We artificially extend the testing field, let's say. So let's say we identify that for a certain function, a cut-in was a critical situation, then we make the cut-in, and this is the beauty, I would say, from scenario-based testing in simulation. We make the cut-in quicker, sharper. However, I mean, you have lots of parameters that you can tune, and we do that in simulation, and then obviously go back into real testing at the end again. Yeah. That's one approach, alongside with corner case detection and so on. But pizza, okay.
No, we still have 4 minutes. That's what the clock is
But I had
telling us.
one thing to say.
But Jens wants to share with us also, I think, how he's motivating the controls people. I think because my understanding is you're also giving them the usual interfaces so that they accept more the simulator.
Yes, in the end. The calibrator, especially in the lane keeping case, complains on the proving ground. I want to calibrate the 500-meter radius. It's on this test track. I've drive this radius once, do my calibration adjustments, and then take a complete lap around all the other corners to repeat my 500-meter radius, because that's my data point I currently work on. And in the simulator, it's that easy to write a script. I asked him, how do you want to have it? It was 3 seconds on the radius, it is 10 seconds on the straight, and then next radius in other direction, please. There we are. It's a script to set up this lane, and he has corners without end. He don't need to slow down the car to make his adjustments, but either he tells the control engineer, please turn that value to that number, or he simply presses pause, adjusts, and presses resume again for the next corner. So even the efficiency of that calibration work, it is much faster. have adjustments of road camber. More is possible and more is easier to do on the simulator. And that's where we got together quite fast for that calibration job.
Let's talk for the remaining time about, you said more is possible. So I think we all know today there is still lots of work done on the real prototypes. So give us some hints. What would be low-hanging fruits for doing more controls work, ADAS work on a simulator? Who wants to start?
Well, I already said, make it easier for all the non-simulation people to use simulation. Okay. Either by make it easy to describe maneuvers, access the tool without even knowing that a tool is behind it, and just like make it easy to use. Because the amount of, well, we have loads of simulation engineers here, but the amount of simulation engineers is limited. And as soon as you tell somebody, you can use simulation, but you got to simulate yourself, you're very, you might be very alone around the table.
You have somebody very lost.
Yeah. So make it easy and make it available.
Yeah. 100% agree. I think that the key word is awareness outside our simulation people circle, and awareness that simulation is a state of the art. Of course, not for every scenario, but at least for some scenario, like the most standardized one. And then awareness also and acceptance from homologation institution, for example, for simulation data as a proof that the system is working. So this is, for me, the most, the closest step that we have to take.
I would like to add one thing, make it easy in using and also in the post-processing, because I guess the post-processing in terms of what do I do with the result from a simulation, that is also key to whatever, a function developer, for instance.
That would be a groundbreaker.
And the standardization of data again.
Engineers who didn't do their own plot tool.
Say it again.
A generation of engineers who haven't created their own plot tool. That would be really a revolution.
In the end, it comes down to the point, no requirement without test and no test without acceptance criteria. So it should be easy that the function owner defines a test, tells some test engineer in a form, in a normalized language, what to test and when it's passed.
So all of you, this was a call for paper. So for the next Zero Prototype Conference, you're invited to talk about how you made it easier, how you made simulation accessible to non-simulation experts. And so we accept abstract submissions from tomorrow on. So with this, thanks a lot. So I enjoyed it. So thanks.
Shall we think?